Hi there. Let's find the distance between a point and a line. Specifically, we want to find the distance between the point 4, 1 and the line x plus 2y equals 10. To get started, the first thing we should do is create a graph of the point and the line. So we have a y-intercept at 5 and a slope of -1/2, so something that's going to slant downward a little like that. Our point has a y value of 1 and an x value of +4, so it's going to be over here. Now the distance is going to be the length of the segment that goes from the point to the line and is perpendicular to the line. To solve the problem, to answer the question, we need to find out exactly where the intersection point is. And when we have that value, then we can compare the coordinates of the intersection point with the coordinates of our original point and find the distance. So let's get to work. What I want to do first is figure out where that intersection point is. But to do that, we need to have an equation for the perpendicular line. Well, I know the slope is going to be +2 because perpendicular lines have opposite reciprocal slopes. And I know a point on the line is at 4, 1. So one way to figure out the slope-intercept form of the line would be to count backwards. I'm going to drop down to 3, -1, 2, -3, 1, -5, and finally the perpendicular line is going to hit a y-intercept at -7. So I know the equation of the perpendicular line is y equals +2x minus 7. So the intersection point is going to come from solving the equation -1/2 x plus 5 equals 2x minus 7. The right-hand side here comes from our perpendicular line. The left-hand side comes from the original line. So we can solve that. I would first multiply by 2 to get simply -x plus 10 equals 4x minus 14. Combining like terms, we see that 24 is going to equal 5x. So x equals 24 divided by 5, or as a decimal, we could write this as 4.8. And then to find the y value, I can plug this into one of our equations and see that y is going to equal 2 times 24 over 5 minus 7. Well, 2 times 24 over 5 is 48 over 5. 7 is the same as 35 over 5. And so we see that the y-coordinate is going to be 13 over 5. So the coordinates of our intersection point are a little awkward. The coordinates together are 24 over 5 for x and 13 over 5 for y. Now what I'd like to do is see how far away that is from our original point, 4, 1. So let's use the distance formula. I'm going to take the x-coordinate of 4 and subtract 24 over 5 and square that, and then add to that the y-coordinate 1 minus 13 over 5 squared. And all of that we take the square root of. We can think of this 4 as 20 over 5, and so that gives us -4 over 5 squared when we subtract. I can think of this 1 as 5 over 5, so that gives me -8 over 5 squared, and the whole thing is under a square root. So now we have 16 plus 64 from the two numerators over 25, the common denominator squared. So that's going to be 80 divided by 25 under a square root. Let me simplify that to become 16 over 5. And now we can split square roots across numerators and denominators, so I can take the square root of 16 and put the square root of 5 into the denominator. So that represents the value of our answer, but it's nice to not have square roots in the denominator, so let's multiply the top and the bottom by the square root of 5, which gives us a better final answer, 4 times the square root of 5 divided by 5. And there we have it. That's the distance between 4, 1 and the line. Since it's talking about distance and we can see it on a graph, one last thing we can try is to find the approximate value. Typing this final answer into a calculator, we should see something in the neighborhood of 1.7889. So in mathematics, it's nice to describe things exactly, which often means using fractions or radical signs. But looking at it and comparing it on the graph, it's nice to have an approximate value to judge whether it's a reasonable answer or not.